Hello everyone, and I'll just check, it's 30 minutes speaking, isn't it, and then 10 minutes Q&A. That's roughly right, fine. I'll get a beating. Oh, I don't want a beating. I want a friendly word. Talk faster. You've already told me off. So I got told off yesterday by Thomas for speaking too fast in my lightning talk, so I shall attempt to wind it back here. I do want you to understand what I'm talking about, so if I do speak too fast, just wave at me, tell me to go slower, it's totally fine. I don't want to cut you out just because I'm getting excited and talking too quick. To that point, am I understandable at the back? Am I loud enough and clear enough? Nods, shakes, no nods? Great, cool, okay. And another public service announcement. There's a sign-up form on the front desk if you want to volunteer to help the Berlin crew organise the future meetups and the conference next year. I strongly urge you, of course, given my lightning talk, to contribute to the community. So if you're interested, it's not binding, you can back out later if you want. Go and sign up on the front desk. Right, so I'm going to talk on statistically solving sneezes and sniffles. This is a research project that a few of us are running in London. I spoke on this at PyData London a couple of weeks ago at our conference there, and this is a slightly updated version given a little bit of work that I've done in the last couple of weeks. So I gave the talk with my colleague Giles, so he's not here, he didn't make it out. So I'm an industrial data scientist. I've been working applying AI to industrial problems for 15 years. My colleague Giles is a bioinformatician turned into a data scientist. He's working with me in Model Insight, that's my consultancy, there's 3 of us in there, and our client in London at the moment is a company called Indava. They're in the slides because they were sponsoring us, they came in as a gold sponsor, so I was very happy to have them along to meet the Python community. And I've written the High Performance Python book with O'Reilly, so if you want to talk about high performance, you're very welcome to come and fire questions at me. So, my wife sneezes a lot. She's really bored of sneezing. She's been sneezing for 30-odd years. For a long time, she thought she was permanently ill. And then one day she had an antihistamine, and she was not ill anymore, almost within like 2 hours. And then she realized that she had some kind of reaction, but it was a persistent, chronic reaction. So something was going on that caused her to sneeze. So then for 2 decades, she took antihistamines, roughly 1 every other day, thinking, hey, that's totally cool. And somewhere in there I said, you know, I'm not sure taking a drug every other day just so you can breathe is cool. Maybe there's some underlying things going on that we should try and solve. And wouldn't you know it, I'm a data scientist, so maybe we could use data to somehow empower some discovery. So one of the goals of this project is to see if we can understand the drivers of allergic rhinitis, or rhinitis in general, to give an individual a chance to use like a quantified self approach to measuring their reactions to a thing. Could be something that causes sneezing or other things, any other reactions. Can you quantify enough things and then use something like machine learning to try to identify the things that are driving the symptoms that you've got? So a personalized medicine approach. So we're making this up as we go along. This is a totally novel piece of work for us. And a long-term goal would be, can we help people reduce their need for medication? About 10 to 30% of people in the world have some kind of rhinitis reaction, often allergic, but it can be non-allergic. So maybe you are allergic to a cat, or you have a non-allergic response to weather symptoms. Some drugs, these anticholinergics, have recently been linked to diseases like Alzheimer's. So although most of the antihistamines are believed to be benign, we don't know what the long-term effect of taking them is for your entire life. And maybe taking a drug every day for your entire life is a bad thing. Maybe there's some underlying things that are really bad that we only discover much later, like Alzheimer's. So if we can provide any mechanism for someone understanding the drivers of their symptoms and then changing their behavior, that's probably a good thing. So I said that my wife sneezes a lot. So chart on the left, that's days where Emily sneezes n number of times. So she can sneeze 0 times, that does occur like 20 days a year, or she can sneeze 1 time a day for about 20 days of the year. She sneezes typically 5 or 6 times a day, and she can sneeze up to 26 times a day. It's a lot of sneezes. These are days when an antihistamine has been used or has not been used. So she can have an antihistamine and sneeze 26 times a day. So she's sneezing a lot. On the right, which days does she have an antihistamine? Well, it turns out roughly half the days of the year she has no antihistamine, roughly half the days she has one antihistamine, and very rarely she has two because her symptoms are so bad. So here's a hypothesis. My wife Emily suffers from non-allergic rhinitis. We've done some experiments with the cat, with me, with other things, trying to figure out if there's an allergic driver. Emily's symptoms predate me and the cat and living in London and other things, so we're pretty sure we are not allergic drivers. That leaves non-allergic rhinitis, and it turns out with rhinitis, there's the allergic condition, which is fairly well understood. There's infectious, you sneeze when you've got a cold, that's fairly well understood. And there's non-allergic, that's everything else, and it's accepted that it's poorly understood. But some things like weather are known to influence that. So possibly the use of antihistamine is driven by weather. Possibly alcohol makes things worse. Emily's noted that she's self-reported she drinks alcohol and then maybe she sneezes more. Pollution might be a factor. Somebody in London suggested that maybe I tried double-blind trials or placebos on Emily to see if the antihistamines are really working. She would kill me if I did that. And we don't believe that antihistamines don't work. We're very confident they do work. So we're not testing for whether antihistamines work. And I'll show you some data there. We want to know what drives the usage of antihistamines in the first place. So Emily's a senior engineer and she works in Mozilla, so she's an iPhone developer, so she can make an app to record this data. So she's written an open source iOS app. Whenever she walks around, it logs location changes, so I get a GPS trace. When she sneezes, she presses a button. When she has an antihistamine, she presses a button. She plays with a cat, she presses a button. So we get a really rich data set over a year now of her behavior, where she is, and what she's being exposed to. There are some fun data collection issues that will occur. I was ranting about this at lunch. So it turns out Apple have a date time encoding. They have an epoch that is different to the Unix epoch of 1970. It's approximately 2001 and a few days and hours different, which makes for fun decoding. We quickly switched to ISO 8601, the unambiguous date representation format. I implore upon you all, please, whenever you're doing date time stuff, use ISO 8601. It makes life easy. And GPS. When Emily's underground, so on the London Underground transport system, she has a sneeze, she taps the button. The GPS confidently reports you are at GPS 0,0. You're definitely there. And that's off the coast of Africa. She's definitely not there. So it's a bit weird that the OS confidently reports a lie. So there are these little fun things that always come out in these kind of projects. Oh, and there's in reflection, we realized there was a bit of weak experimental design that's hard to get around. We're logging positive events, so one sneeze, one sneeze, one sneeze. If there are no logs in a day, does that mean there are no sneezes? Or the phone was left at home and Emily couldn't do the logging? So for frequent events like sneezes, we get lots of evidence, that's pretty cool. For infrequent things like alcohol usage, the lack of recording a positive occurrence has an impact on the experiments that we can run. And there's no good solution to this apart from really logging with a camera, trying to monitor everything all the time. And we're not at that stage yet. So just to remind you, Emily sneezes a lot, and we want to predict what drives antihistamine usage. So here's a log of a year's worth of sneeze and antihistamine usage. So the timeline is April last year through to March this year. At the top, these are sneezes per day. So some days, typically 5 or 6 sneezes a day. You can see that bouncing around. You can see the 26 sneezes mid-November, some crazy bad day for who knows what reason. On the bottom chart, it looks like a barcode. There's one line if an antihistamine was taken in that day. I don't represent 2 antihistamines, just when an antihistamine is used. So you get tight-packed regions around June. That's where antihistamines are being used a lot. And then there are regions of white. That's where antihistamines aren't being used frequently. So you can see it kind of comes and goes in waves, but there's persistent sneezing and persistent antihistamine usage throughout the year. There's also a gap in the middle of May, 5 days. That's when we did, or Emily did an iOS upgrade, and it helpfully just deleted everything. Didn't say I'm going to delete everything, it just wiped everything, all the projects, all the data, all the everything. We only lost 5 days, but it was kind of embarrassing. After that, we started using segment.io as an external data log to avoid any future data loss. So you might ask, is there structure in this data? And there is. So on this plot, we've got Monday through to Sunday. So this is a year's worth of aggregated data looking at each day of the week. So Monday through Sunday by 24 hours of the day, and a histogram per day. So it's the average behavior on a Monday, Tuesday, Wednesday. And we can see that at 8 a.m., there's a peak in sneezing. So we wake up, Emily sits up, she sneezes. And that's a very typical behavior. And then the sneezes drop off. And then on Saturday and Sunday, we wake up an hour later. So the sneezes occur an hour later. So there is structure in this data. The sneezes disappear during the day, and then they tend to increase in the evening. We don't know why, we don't know what the biological reason for that is, but we observe that behavior. It's very clear that something is going on. What about antihistamine usage? Well, it's a similar behavior. If Emily wakes up and she's sneezing a lot, then she has an antihistamine first thing in the morning. So we typically see antihistamine usage first thing in the morning, Saturday and Sunday later in the morning, kind of more smudged out as well, which is an interesting thing. We don't know why, it just works out that way. And in the evening, if she's had a really bad day and she can't breathe and she's sneezing a lot, she'll have an antihistamine so she can sleep well. So that's the antihistamines in the evening. And this begs an interesting question about the data. If we're predicting what drives antihistamine use, is an 11 p.m. antihistamine driven by the day's factors? It probably is. But the 8 a.m. antihistamine, is that driven by the day to come's factors? Probably not. Is it driven by yesterday's factors? Probably. But if I'm predicting on a daily basis, where do I slide the data? How do I deal with that? And there is no straight answer. It depends on which question I'm asking. So, do I find any obvious relationships in the data? Well, I can tell you one that's going to be no surprise. Sneezes and antihistamine usage are related. So here, I've resampled the data by 3 days. This is a seaborn, using for the plots here. So with seaborn, I've resampled with pandas by 3 days. And then in 3 days, if Emily uses no antihistamines, that's the left plot. If in 3 days she uses one, it's the next one. If in 3 days she has one antihistamine a day, she uses 3, which is the third one, or the fourth one, sorry. And then on some rare occasions, she's used 2 antihistamines in a day, so in 3 days she's used 4 in total. So those are the box plots, and the y-axis is sneezes. So when she's used no antihistamines in 3 days, also she sneezed the least frequently, because whatever's driving the sneezing is not that bad. When she has 3 antihistamines, then the average number of sneezes is higher, and we can see a linear relationship in there. So it looks like there's a nice relationship. It's not surprising, right? She sneezes a lot, she uses antihistamines. It's not the biggest surprise. If I didn't find that relationship, I'd be surprised, because that feels like it should be fundamental, and it's there, so that's good. And in the bottom right plot, I flip that around. Can I fit a linear regression using sneezes to predict antihistamine usage? And it's using a linear relationship to predict an ordinal value. So it's not super great, but we get a line through it, showing a linear relationship between these, the inputs and the response. And I validate that later with cross-validation. So how long does an antihistamine last for? So this is a nice bit of just empirical work we can do on the data. So the left-hand plot, there we've taken 67 occurrences of antihistamine being used in the morning. So if Emily wakes up, sneezes, takes an antihistamine, we then look at the next 12 hours worth of data to see how many sneezes she has per hour for 12 hours, just like Valentin, but only in the morning. We do it in the morning because I can't get 12 hours of trace if I take the afternoon or the evening sneezes, because then we're asleep and then there's no sneezing. So only for morning antihistamine use, how many sneezes per hour afterwards. So we get this confused plot, not super easy to read. The plot on the right is the cumulative chart. So we just summed up all of these sneezes. So on the 0th hour of taking an so I take an antihistamine right now, Emily takes it, and then how many sneezes in the next hour? That's that large count where the mouse pointer is, about 47. 1 hour later, similar number of high sneezes. 2 hours later, it drops down massively. And then 3, 4, 5 hours later, very low number of sneezes. And after about, by the 11th hour, things begin to get worse again, sneezes go up. So the antihistamine is effective. It takes about 2 hours, according to this, to become effective, and then it's effective for most of the day. So it's great. This antihistamine, loratadine, works well for Emily. Great. The dotted line, that's a simulation of antihistamine distribution in the body. So its biological effect is that it takes 2 hours to become distributed in the body in the first place, and then there's an 8-hour half-life and it drops off, and so we get that exponential drop-off. So it's nice. It takes 2 hours to get into the body, and it takes 2 hours before we see it take effect. So if you wanted to experiment with different medications and different quantity of medications, perhaps, you could do this kind of experiment and look at the data. So this feels useful if one is trying different drugs. So what kind of relationships might we learn out of this? So we know that antihistamine is used roughly 50% of the time. So we've got a binary classification problem, or at least we can treat this as a binary classification problem. And that was the first attempt that we took on this data. What can we learn about what might drive the use of antihistamines from external data sources? So can we use logistic regression, simplest possible classifier that's very interpretable, to feed in some data about daily environment, coupled with the response variable, antihistamine used or not, and then using approaches like randomized cross-validation, so shuffling all the data over the year, not taking it as a linear time sequence, but shuffling all those days up, trying to break any local relationships, and then doing cross-fold, tenfold cross-validation, looking to see if we have a reliable prediction. So do any features give us a reliable prediction? What kind of features might we use? So on the left, we've got weather. So this is a plot of, I think here, 5-day resampled data to try and amplify the effects. So 5 days of lots of antihistamines or few antihistamines. That's the turquoise, thicker plot. And then the dotted lines is humidity on those days. So can we see a relationship? And, you know, not really. It's kind of hard to see that in that time series plot. But if we flip the data around into a scatter plot, we can see another linear relationship. It looks like there's a relationship between humidity, in this case, and number of antihistamines being used on a 5-day resample. So that's something we can test in the model. And on the right-hand side, I've got a screenshot from the London Air app. This is, I think it's a King's College project. I think it's King's, gathering data from about 50 monitoring sites over London, looking at NO2, PM2.5, and PM10 particulates, and then modelling London's pollution as to how it changes on an hourly basis. So can we take that kind of data and put it into the model as well, and see if pollution, particulate pollution, is driving some of these reactions? So we take the raw data, we put it into pandas data frames. We're taking weather. The weather, importantly, is coming from London City Airport. So it's not Emily's weather around exactly where she is, wherever she is in London. It's the weather from the airport with a really good sensor set. So the features may or may not be correlated just by distance. We can take, in this case, we also add in MyFitnessPal. So when alcohol is used, then Emily logs it in MyFitnessPal. I wrote a scraper to take the London Oyster system, so the transport network's recordings. They give a PDF that you can look at to see when you took certain transport methodologies. So I then take that, and then using text extract, I parse that and then pull out when different buses and trains were used. The northern line is known as being the black snot line, so it's got lots of particulates in the air. Everyone blows their nose on it and then has horrible snot. And that's a well-known thing in London. So is it the case that that kind of particulate pollution is driving some kind of reaction? We take the raw data on hours or daily samples, and then we do things like make a 3-day rolling average and a 10-day rolling average to try to smooth out the noise and get a general trend. Difference in direction, so are we decreasing on our trend or increasing? Is there a crossover? And we create a number of fabricated or synthetic features based off the raw data. So we go from about 20 original features to about 84 synthetic features in total with the moving averages and the like. And we've got 330 rows worth of data. So we've got a pretty good data set to work off. It's not big data. This is a tiny data set. This is kilobytes of data, even though I've added new features in. So how do I build a model? Well, one of the two approaches, top down, bottom up. So I can start by adding one feature at a time and seeing which ones work, and do univariate feature selection that identifies a bunch of features like the humidity, so that's great. Or I can throw all the features in and then see what happens, and I get a rubbish model. It's really unpredicted. There are too many confounders. And I can use a recursive feature elimination process to pull out one feature at a time. Actually, I wrote a thing that tries all the possible combinations in all the possible ways with many cross-validations, trying to see if we exhaustively enumerate all the possibilities, can I come up with a good subset of features, just to see what would come out of that. And it keeps on coming up with a simple answer. Before I get to that, no, I'm on that answer now. So, on the 1 year model, I come up with a simple answer, and the simple answer is no features are predictive over the course of 1 year. And this led me to the question at the bottom. Given that I'm using things like external weather, and Emily, for a bunch of months, didn't have a permanent job. She was freelancing, so she was working from home, so she was affected by the normal weather. When she took the job with Mozilla, she was in an air-conditioned office. She's no longer affected by the external humidity, because the internal humidity and temperature are different, and I'm recording that. And so we realized that there are different weather effects going on. So, what if we subsample just a portion of time and try and build a model? So if we take the portion of time when Emily is not in an air-conditioned office and she was working from home and she's affected by the weather which we're taking as our inputs, the London general weather, then I can build a predictive model, and this feels kind of important. So we see with logistic regression, sneezes, the middle factor, these are standardized data, so it's a strong positive weight. The more sneezes she makes in a day, the more likely she is to have an antihistamine. So great, that's the relationship I saw earlier and it's come through. I get a negative relationship with humidity. The damper the air, the higher the number, the lower the likelihood of antihistamine. The drier the air, the more likely the mucous membranes get dried out, the more likely an antihistamine. So that's great. And I get this sea level pressure. I don't know what that's doing there. That's a bit of a weird one. But this feels like I've kind of discovered something here that might actually affect her symptoms. It might explain some of her symptoms. And this is actually a summary of 5,000 independent models built with cross-validation, looking just to see if the coefficients in the model ever cross the zero line, or if they stay on one side of the zero line. Is it a robust model? This is a little variant I'll just run through very quickly. If we want to look at how the coefficients might vary over time, what if we train on a sequential piece of data, so 60 days training, and then test on 40 days? That gives me a test score. That's 1 point on the bottom chart. And then I shift forward 1 day, and I test on, or train on 60, test on 40, I get a 2nd point. That's the next point on the score chart. And we can see our predictive scores are above 0, or above 50%, dips down, then it gets better. If each time we build one of those models, we pull the coefficients out, we plot those coefficients on the top chart, and the colors didn't come through very clearly. The smallest coefficient near the -1, that's the humidity. So humidity is predictive for some number of months. Emily gets a job in an air-controlled environment, and then that relationship goes away, and it comes back again later. This feels like something I can discuss with an academic, and that's a collaboration we've got starting in 3 weeks' time. So this is trying to pull out explainable features over time to see what seems to be truthy for at least periods of time when we've got good data. So can we do some new experiments? Emily doesn't go to work on weekends, so I can subselect weekends over the course of a year and see if she is not affected by air conditioning on the weekends. And it turns out the model holds true over the weekends over the course of a year. So that gives further evidence that maybe the humidity in this case is affecting things. We didn't gather consistent alcohol usage, so I couldn't make a good model of whether alcohol increases the propensity to sneeze. So we've started a new 3-month experiment. Every time Emily drinks something, she logs it inside the app. Every time she drinks alcohol, it's logged in the app. And we have a Bayesian modeling approach with another colleague looking at that. At home, we've got a hygrometer, a digital blue air hygrometer. They've got an API, but it's not public. So I'm asking them, can I get the data out of that? If I get that, I get humidity for the home as well as for the street outside. And I can increase the quality of my modeling. And then the final point about moving house. Well, maybe being in North London in a polluted environment, maybe that's a bad thing. We're going to move house shortly outside of London. Maybe that changes symptoms. Maybe we can see that just in the data log. That'll be kind of interesting. So which tools did we use? We were doing some work at the beginning with R, so we used HDF5 for data sharing between pandas and R. Pandas, I live in pandas for this. Pandas is amazing. Notebooks rendered on GitHub with a Slack channel, so I can do some work, render it, check it in, and then my colleagues can follow the link in Slack to the rendered diagram and see it in Git without checking it out and running the models. So that's a really easy way to share results in a private group. I've used versioned data frames, so I've actually versioned the file names. It's all under Git control. So it's not, there's no super strong provenance, but at least there is a fully rebuildable history behind this. And if you haven't come across in the notebook, Min, the author, one of the authors of IPython, he's got some great channels. The Scratchpad, Control B, you get a temporary window, you can type commands in, or you can get the, under the IPython extensions, you can get that little button, the arrow and the underscore, and that calls up a temporary Qt console. These make working almost like an IDE in the notebook really easy, so I strongly encourage you to try those. So where do we go next? We're on our second year of data collection, still with one person. So we want to expand this out. So we've now got several people using the apps. We've got several subjects recording different symptoms. They will all have different drivers for their symptoms, so that the challenge gets harder and harder. But hey, I get new data. I get new things to think about. Rather than trying to predict daily antihistamine use, what if we're trying to predict 3-day aggregate use? So if I aggregate my symptoms to look at worse or better symptom days, maybe I get like an amplified response and I can regress rather than classify. I have a question for you all. I'm assuming, using logistic regression, well, one of the assumptions of logistic regression is that you have identically distributed and independent data. My weather data is not IID. Today's weather is best predicted by yesterday's weather. It's strongly correlated. Pragmatically, I get good predictive results, and I'm pretty happy with that, but I don't know the math behind this. I'm not sure I'm making the right assumptions. Maybe some of you have worked on this kind of problem with a time series and strongly correlated data, building up individual predictors. If so, I'd be very keen to have your feedback afterwards. We've got a collaboration starting with university shortly. They don't know machine learning, but they know how the body works, so they can validate if these assumptions that we're making make sense. Does this humidity result, does that really translate to reality? I'll be really interested. That's 3 weeks away, so I hope it's true, or I feel a bit silly, but we'll learn something. And the final thing is, of course, I could strap sensors to Emily. The whole Borgification project, she's not terribly keen on that, but there's a big rise in the Internet of Things sensors and things like the Atmo tube. It's a $70 device. You can hook it onto a handbag or a backpack, and it runs for a month on Bluetooth Low Energy, and it records pollution and humidity. So I can get a month's worth of logging unintrusively. And we're only going to see an increase in the sensors available that we can either put on our clothing, our bags, in our phones for logging this kind of thing. So it's a challenging problem. We believe that we found one driver of the usage of antihistamines for Emily, and we've got a methodology that's reproducible. We'll validate it with the academics, and then hopefully we've got the beginnings of something that we can roll out to more people. We can answer the question, are antihistamines effective? We can see that. We're not yet sure if alcohol is affected by sneezes. Anecdotally, we believe that is the case, but we don't know for sure in terms of the data. And I've got no data yet to say that air pollution is a driver of Emily's allergies. I want to find that because we can do something about air pollution, but we haven't found that yet. And these are all the tools, all the regular tools. This wouldn't be possible unless this was all available, so I give props to all of these projects for making this possible. Thank you very much. Have any questions?
Thanks, Ian. Yeah, you were taking questions for 10 minutes now? Yes.
So I'm curious if it would be possible to give your wife antihistamine every morning and then see whether it has an effect on the sneezes or not. At least for like a trial period of like a month or two.
Right, so in the past, she's gone through phases of taking an antihistamine every day, only when symptoms are bad. Before we started the study, she was in kind of that protective phase where she was just taking them as a matter of course every morning when waking up. And then we discussed it and said, well, if we want to predict the driver of antihistamine usage, you need to be only using them when you need to use them. So she then switched to only using them when required. all I can really say is if she takes one every morning, her frequency of sneezing will go down and the concentration of the drug in the bloodstream will go up, and I will learn nothing about anything else. Although if I control for antihistamine usage, I will see variance in sneezing per day, and I could maybe regress on sneezes rather than antihistamines. But yes, the point of the project is to try and use less antihistamine, not more, so I prefer to keep that.
Yeah.
Okay, so I have actually I have a few questions. First one is it possible to make a blind trial?
Sorry, say again?
Is it possible to make a blind trial in the sense that if she's taking it only when it is bad, it's correlated, so it's not like, so there's sneezing, something sneezing.
So I don't care about the sneezing per se. I care about what drives the decision to take an antihistamine, and that must be correlated with the factors that I want to discover.
Okay, so
I care about that correlation because I want to find it.
And the second thing is that it may be likely that, average number of sneezing is not the best number you can predict. So did you try making some Bayesian models that...
So I'm not trying to predict sneezes.
Okay.
I don't care about sneezes.
Okay.
I care about antihistamine use.
Okay.
Sneezes is the thing that causes Emily to take an antihistamine, so it's that intermediate factor that I'm trying to predict. But one of the things we record is the sneezes. But I'm not trying to regress on sneezes.
Okay, understand.
And yeah, it's a bit of a weird one to get. We actually spent a lot of time arguing. We did try regressing on sneezes, having predicted antihistamine concentrations, because it felt like sneezes was the right thing to try to predict. But then we realized there are so many confounders in the way. Really what matters is, if Emily has an antihistamine, what has happened in the run-up to taking that event that might drive that event, and when on the days when there are no antihistamines, what has happened before that might be different that drives not taking an antihistamine. And that's what we're trying to find. Can we manipulate the environment to make taking an antihistamine less likely? And as a consequence, sneezing less likely.
Do we have more questions? Yes, we do.
Thanks for the talk. It was great. I'm curious about, is the same antihistamine used every time, or
Yes.
have you tried different types of antihistamines? I know that there's several available that basically use different medical approaches to solving that problem.
Absolutely. If another antihistamine is used and Emily sneezes less for a couple of hours, we learn that that antihistamine is a bit more effective. We don't learn what causes her to take an antihistamine. I would like her to never take an antihistamine again because we fixed the environment. If it's the case that running a HEPA filter to remove 99.97% of particulates from the air solved the problem, and we've tried that experiment, that would be great. I couldn't strap one to her, but we could at least clean the air in the home, for example, and then reduce the dirty air that was the driver. We've tried that experiment. So I don't really care which antihistamines are more or less effective because they don't solve the underlying problem. I want to solve the environmental factors that cause the use of antihistamine in the first place.
Yeah, and have you also tried different bedding or tried different...
4 months ago, we dumped the old bed and we bought a new bed. Antihistamine and sneeze behaviour the same.
Okay.
We did also try, dust mites live in all of our houses and our clothing. You can desiccate them at 50% humidity, so we then ran the humidity in the house for 3 months at 50%. No change in behaviour there. Then we discovered that maybe humidity actually affects the propensity to sneeze, and maybe 50% humidity was drying out Emily's nose a bit, and maybe that was a bad thing, so we stopped doing that. Tried quite a lot of experiments. The cat did not like being shut out of the bedroom for 3 months as well. She really didn't like that one. Any other questions?
Have you had any experience with going on holidays, or maybe abroad, leaving the country, so an entirely different environment?
Absolutely. So, and when I mentioned at the beginning that I'm fairly certain that, because some people have said, hey Ian, maybe you're the cause of the allergies, right? So we've been together for 9 years, and she's been sneezing for 20 going on 30, so it's not just me. We used to live in Brighton. She sneezed there, less so, but she did sneeze in Brighton. And via this company and previous companies, she's worked in other countries, either with me out there or with not me out there. And she's been working in Canada, the US, and throughout Europe, and for up to 2 or 3 weeks at a time. And although the antihistamine usage varies a little bit, it's basically every other day. So the underlying use of antihistamine seems to stay, which is kind of interesting, because that means different pollens in the air, different pollution in the air, different foodstuffs, different alcohol patterns, and yet this thing goes on. So what the heck is causing the sensitization? And I don't know, data must have the answer.
Yeah, sorry, and do you track physical activity or exercise, that kind of thing?
Say again, please?
Exercise or physical activity.
Right, so, and that's something we've discussed. With MyFitnessPal, Emily is logging her exercise. Exercise stresses the immune system, and so there could be a driver there. I haven't pulled the data out of MyFitnessPal for that to see if that correlates. Emily has no anecdotal direct notions of a relationship between exercise and her propensity to sneeze. She doesn't exercise every other day, so there's no immediate relationship, but there could be a relationship. One of the problems is that MyFitnessPal have no API. Somebody wrote a Python 2 scraper. I updated it to Python 3. For anyone upgrading to Python 3, it took me 2 hours, and that's a web-enabled thing with bytes and all the rest of it, only 2 hours. So I did that, and we got the food data out of MyFitnessPal, but the scraper didn't include scraping the exercise data. I've written quite a lot of scrapers for this so far. I haven't written that scraper. If someone else wants to write that scraper, that'd be lovely. But no, I agree, that's something to test. I just haven't tested it yet.
Hello, a very interesting lecture, especially for personal reasons. What is the result of allergy tests of your wife? Because you try to find the environmental reasons,
so we've not
but
done
normally you
tests.
run allergy tests to see something, and I don't think you have mentioned any results of this.
So we haven't done allergy tests. Emily spoke with her doctor and they said, well, unless you can tell us what you're allergic to, we can't test for it, and there's a billion things we could test for, so we're not going to do it unless you've got a strong suspicion. And we said, well, we strongly don't suspect that the cat or lactose or dairy or other things, at which point, at least under the doctors that we've spoken to, they said, well, there's no point doing a test, which is partly the reason for going to see the academics, because the academics are offering to open up some interesting links to people who might know what to test. And so that feels like a far more structured way to go than just going via the National Health Service. So we want to do that, we just haven't got to that yet.
So in Germany, you can get screening for all sorts of allergies.
Right.
You can just go to the doctor and say, I'd like to be tested for like 50 different things, and they'll do it. So maybe you should come here and have the allergy
Germany,
test.
right? Okay, well, new environment, new data.
The advice is move to Germany.
Okay, move to Germany, fine. Am I out of time?
I think you are.
Okay, thank you very much.
Let's give a hand one more time to Ian for a great...